in this problem, we're given 92 flips of a coin. So this could be our coin here. And we have 92 flips. And all of them show heads. Now, two observers see this and they argue amongst themselves whether seeing a sequence of 92 heads and no tails is evidence against the coin being fair. So the first observer says that for a fair coin, a sequence of 92 heads, this is 92 here, is extremely unlikely. And so the coin is likely biased. The second observer says that for a fair coin, any sequence of 92 flips, so let's say the sequence A sub 1, A sub 2, all the way to A sub 92, any such sequence has a probability of 1/2 to the 92nd power. And because this is true for all sequences, observing any particular sequence, in this case the sequence where everything is heads, gives us no information about the coin being any less fair, because all sequences have the same likelihood of occurrence. We just happen to have the sequence where we have all heads. So in part A, our goal is to try and understand which of these two observers is correct. Does observing 92 heads and no tails, in fact, make it more likely that the coin is biased? Well, the key here is to note, that we are not interested in the probability of the particular sequence of all heads, but rather the probability that a sequence has no tails in it. So this is what we'd like to understand. What is the probability given a fair coin? So given a fair coin, how likely is it that a sequence has no tails in it? So when we frame the question in this way, then we can say, okay, well, if we have 92 slots, there's only one way of getting all heads. There's one such sequence. But if we have 92 slots and let's say want to fill them with 45 heads and 47 tails, well, that is 92, choose 45 such sequences. Maybe we have heads here, and the rest are tails, and then some more heads in the middle there. But there are 92, choose 45 such sequences. So what this tells us is that there are many more sequences. There are many more sequences in which there are tails. Right? There's only one sequence with all heads, but there are far more sequences with a mix of things, mix of heads and tails. So what this tells us is that it is, for a fair coin, it is unlikely that we get this particular sequence with all heads. It is far more likely that a sequence we get has some tails and some heads in it, since there are many more such sequences. And so the first observer is correct in their thinking that there are many more sequences with a mix of heads and tails, and there's only one sequence with all heads, and so this reduces the likelihood that the coin is fair, even though the probability of each sequence is 1/2 to the 92nd power for a fair coin. So now we'd like to formalize this in part B, and for that we're going to make a couple of notations. We're going to denote by F the event that the coin is fair, and we're told that the prior probability that the coin is fair is little p. And we're also going to denote by H the event that the 92 flips are heads. And what we'd like to show what we'd like to find out is the probability, the posterior probability that the coin is fair, given we've observed 92 heads. So we're going to apply Bayes' rule and the law of total probability. So this is the prior probability of the coin being fair, times we observe the probability that we observe 92 heads, given that the coin is fair, over, we copy this result from the numerator, plus the probability that the coin is not fair, times the probability that we observe 92 heads given an unfair coin. So the probability, the prior probability that the coin was fair was little p, and if it's fair, then the probability of observing the sequence of all heads, as we said, is 1 over 2 to the 92nd power. So p times 1 over 2 to the 92nd power plus the probability that that coin is unfair is 1 minus p. And if it's unfair, if it's double-sided with heads, then we're definitely going to get 92 heads. So that probability is 1. So now what we try to understand is if we want to see if this probability here, if this posterior probability is small. If we've observed 92 heads, does that make the chance of the coin being fair small? Now the thing we want to notice is that looking at the expression we found here, for the probability of the coin being fair given that we've observed 92 heads, for this to be less than 1 over 20, little p needs to be less than 2 to the 92 over 2 to the 92 plus 19. Now this value is approximately equal to 1. So what this tells us is that if p is, unless we are very sure, unless we're really sure, unless p is almost equal to 1, unless we're really sure that the coin was fair to begin with, after observing 92 flips of heads, the probability that the coin is fair is actually less than 1 over 20. So it's a very small chance that the coin is fair. So the way to interpret this is to say that unless we are confident that the coin was fair, the probability of the coin being fair, the posterior probability, given that we've observed 92 flips of heads, is actually less than 1 over 20. And so observing these sequence of 92 heads makes the probability that the coin is fair very low, and so we do agree with the first observer in saying that the coin is probably biased.